Okay everyone, hello and welcome back. My name is Cameron Kirk and this is my tutorial series on how to complete the assignments for the MIT OpenCourseWare Computer Graphics 6.837 as taught in fall 2012. In the previous video, I started to show how you can get the starter code working for assignment 2, and that actually proved to be one of the biggest barriers to get started or even do this assignment, was just to get the starter code to work. But now that we have that, this video I'm going to start to work through the solution for assignment 2. I got the whole thing to work, and actually I completed this project back in August. And then a couple months went by and I haven't quite had some time to sit down and really film the solution video. So with that said, I'm going to sort of work through this one part at a time. I have our project that we created in the last video right here. Everything ready to go, just how it was left in the last video. And on my second screen, I have my code that I developed for the solution, and I also have my OneNote, which sort of shows what I should talk about each step of the way. So in addition to that, this project is much bigger than the other two, so I'm gonna have to take little pauses between each section as we work through it, and I'll just stitch them together using a video editor software later on. But anyways, with that said, let's go ahead and get started. So I have here the assignment, and you can get this from the website. And the first thing we're going to look at, so I do recommend reading through everything on these pages. They sort of explain what we're going to be making. The hierarchy, I'm going to talk a little bit more into it as we're writing the code. But the first thing where we have to write some code is this part right here, 3.1, the matrix stack. And what they want us to do is implement a stack using, it recommends using the standard library, vector library, to implement the stack. And it tells you that you need to look inside matrix.h and matrix stack.cpp. And so let's go take a look at that and see what the code looks like. So we have matrix stack.h. And here you can see we have the class functions here. So these are the different functions that our matrix stack can perform. We have a clear, we have a top, we have a push, pop, and an initializer, a constructor. So the constructor is basically like when you create a new stack, this is where it opens up the constructor code, and it will run each line of code in there to construct the matrix. Clear, let's take a look at the .cpp. So here's the .cpp, and right now nothing is typed in. But as we read through these comments are provided in the starter code. These tell you exactly what you need to do. So for example, we need to initialize the matrix stack with the identity matrix. So if you take a look at the matrix stack class definition, you see here that we have a private member called mMatrices, and this is sort of the data part for the matrix stack instance when you actually create an instance. So the class is saying that for every single matrix stack that you're going to make, there's going to be, each one is going to have its own private mMatrices. And private means that nobody else can get to it, nobody else can talk to it. Just the instance, the guy that you create, the variable you create with the type matrix stack has access to this. So it's sort of like secret to everybody else. Nobody else can get that. Okay, so back over on the CPP, it says here that we want to initialize the matrix stack with the identity matrix. So if I push enter, I should be able to type m underscore, and it took a minute to load, but here it's showing me my private member mMatrices. So I'll autocomplete that, and I'll set it equal to a matrix a 4x4 matrix that is an identity matrix. What am I doing wrong here? Oh, you want it to be dot? Nope. Colon, colon. There it is. Colon, colon. Okay. So if I type the colon, colon, these are the different functions I can get access to in the matrix 4F class. And we want the identity matrix. So let's see if I can flip. I'm using the down arrows to flip through here. Did I pass it? I must have passed it. Identity, there it is. And semicolon. Oh, and I pushed tab to autocomplete that. And it didn't like that. So let me just change this a little bit. Is that what it wants? Oh, no. Okay. So I'm treating this like it is a of type matrix 4F, but actually, if you look closely, it is actually a vector of 4x4 matrices. So this guy is actually a vector. And let's just kind of open up this link I have sitting here in my notes and look at what is vector. So vector is a class, and basically it's like a C++ array, but it gives you a lot of extra features on top of that. So if I scroll down here, we have begin, end. Those are iterators. We can get the size by calling the size function on it. Front, back, push back, pop back. Those are the ones we're going to use because it's going to treat it like a stack. We're going to use push back, pop back. What else do we have? We have clear. So clear will clear the content. Removes all elements from the vector which are destroyed, leaving the container with a size of 0. We're going to be using clear. And yeah, so push back, pop back. That's what we need. So I was very, very poorly trying to do this from memory, but this guy is a vector. So we're going to do a dot push back, and we're going to push back a matrix 4F colon, colon, the identity. We're going to push back the identity matrix. And there it is. And so this is our first function completed. So what we're going to do is basically we're going to build out a stack using these functions, and we're going to make our own custom stack that holds 4x4 matrices. So these comments really just straight up tell you what you have to do to make this a matrix stack. But for those who don't know, a stack is simply like, think of a stack of plates. You can put a plate on top, or you can take a plate from the top, and you cannot take from the middle or take from the bottom. So as you start stacking the plates, you put the first one on, and then you put another one on. And then the first one you can't take until you take everything off. So you get the first in, last out, or FILO, right? First in, last out sort of thing. It's very different from a queue. But anyways, these comments just tell you straight up what you need to do. So we're going to clear, revert just containing the identity matrix. So for this one, we're going to clear our M matrices member. We'll do a clear. And then we're going to do an M matrices dot pushback. We're going to push back. Once again, it's basically this line of code. So let's copy that, paste it in there. Great. And then this one, we're going to return the top of the stack. So instead of a matrix 4F, let's return the M matrices dot top back. It's back. Yeah. Right, so let's just double check on that. Back is access the last element. So as you push back, then if you get the back, it's going to return the last element. So this will return to us the back of the vector, which is the top of the stack. Okay. Next up, we're going to do push. So you got to push M, which we're getting passed in as a function argument here. And then your stack should have OpenGL semantics. I don't know exactly what that means, but don't worry about it. The new top should be the old top multiplied by M. Okay, so apparently that is the OpenGL semantics. So all we're going to do here is we are going to we're going to make a new matrix 4F, and let's call this new M. And this is going to be equal to the M that we just got as an argument multiplied by the matrix. Oh, let's do this the other way around. So order of operation does matter. We're going to do let's do it this way. Yeah. Matrix dot back multiplied by m. Great. And then this will be a m matrices dot pushback, and we're going to push back the new m. Great. So this is sort of the easy part, by the way. We're nearly done with this first bit of, well, basically section 3.1, right? I do recommend reading through 3.1. Just not going to do it in this video. Okay, cool. Let's keep going. All right, so the last function we need to implement is remove the top element from the stack. So this will be a m matrices dot pop back, right? So push back, you push it on, pop, you take it off. Cool. And we're done. This is everything you need to complete the code for section 3.1.